Hello, it's dumplet here. Here's an item on number theory. X and y are natural numbers such that x cubed plus y cubed is equal to the square of x plus y. Find all possible ordered pairs xy. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Alright, so I think one of the most obvious observations from the given equation, the given diophantine equation, it's going to be that x cubed plus y cubed, it does contain a factor, x plus y, which is also present on the right side. So x cubed plus y cubed, that's just simply sum of cubes, so we can factor that as follows: x plus y times x squared minus xy plus y squared. Now, we know that from the given, x and y are natural numbers, so x and y, they're both at least 1. So x plus y, we're adding two natural numbers together, surely it's not 0, and surely it's going to be greater than or equal to 2, so we can safely divide both sides by x plus y over here, and we're going to be able to cancel one of the x plus y, so essentially we're just going to find values of x and y, such that x squared minus xy plus y squared is equal to x plus y. So we're just going to deal with this equation and hope to get something from that one. Alright, now I tried to kind of write this part in terms of x plus y. So I have here x plus y squared minus 3xy, that's going to be x plus y. Maybe I get some of a nice bound with x plus y. And what I realized is that, well, I have a square on the left side, and I do have x plus y, which I know is going to be a positive term. So maybe there would be a nice way for me to write this via completing the square. So what I tried to do is the following. So I tried to consider multiples of x squared minus xy plus y squared. And I arrived at the following. So I can kind of write this in terms of, what I'm going to do is get the square of x plus y, and then I'm going to add it with 3 times the square of the difference of x minus y. Now, this is not obvious at all, but I just got this from a little bit of trial and error and hoping to write in terms of sum of squares, because squares and positive terms, they really go well together because squares are non-negative. So this, if you expand it out, so x squared plus 2xy plus y squared, and then for the 3 times the square of x minus y, it's going to be 3x squared minus 6xy plus 3y squared. And in fact, if you add the 2, you're going to get 4 times the quantity x squared minus xy plus y squared. So this green representation, it is a sum of squares, but what we have to do is kind of divide it by 4. So we will divide both sides by 4 over here. Now, technically speaking, this is already a nice equation, because we have a lot of x plus y, so we can kind of restrict the values. We can kind of restrict some term here, perhaps the x minus y quantity squared, or we can kind of use this x plus y being positive, and we have a lot of non-negative terms going on. Now, there might be other ways to do this, to kind of write the square. One way I thought of like right now is the following. I can write this x squared minus xy plus y squared as x squared plus y squared plus x minus y squared. And if I expand and add them out, that's going to be twice of x squared minus xy plus y squared. So this might be another method. So you might want to try this out on your own, but for demonstration purposes, I will focus on the first one. But hopefully you'll be able to get a similar outcome from this one. Anyways, so we're gonna focus on this green equation that we got, and we are going to make the following observations. So we have a lot of non-negative things. So here we have a non-negative term, the 3 times x minus y squared being greater than the 3 times x minus y squared all over 4, that's going to be non-negative. So we would know that x plus y minus x plus y squared divided by 4, that's going to be equal to this term, so that's going to be greater than or equal to 0. So that's the thing that we'll be able to get, and apparently we can get a nice bound for x plus y. So let's try to get that. If I move this term to the other side, I'll get x plus y will be greater than or equal to the square of x plus y divided by 4. Divide both sides by x plus y, since x plus y is never 0 because we have natural numbers x and y over here. So we're going to get 1 is greater than or equal to x plus y over 4, so at least we can get a nice bound for x plus y. X plus y should be less than or equal to 4. And apparently we just have to consider some cases over here. So we have the range of x plus y less than or equal to 4, and we're asked to solve this equation. Now it's kind of nice that we have x plus y here. So essentially speaking, we can just trial and error, because I mean there's only finitely many values now that x plus y is less than or equal to 4. All right. So if x plus y equals 4, x cubed plus y cubed, that's going to be equal to 16. And from this alone, we can kind of get some ordered pairs, which are possible. The only possible ordered pairs are 3, 1, 2, 2, and then 1, 3. Now, 3, 1, and 1, 3, that's going to make one of these two numbers 27, so that's pretty much impossible. And if we're going to check 2, 2, we're going to get 2 cubed plus 2 cubed, that's 8 plus 8, and that's indeed equal to 16. So we have one solution when x plus y equals 4, and that's the case where both x and y are equal to 2. All right, let's try to do the next case. X plus y equals 3. Now, we're going to have the two possible ordered pairs, 2, 1, and 1, 2. Those are the only two possible. And since x plus y equals 3, x cubed plus y cubed, that's going to be equal to 3 squared, which is just 9. And upon verifying, checking these two, you're going to realize that 2, 1, and 1, 2, they both work. So you're going to get 8 plus 1, or 1 plus 8, both of which are equal to 9. So that's two more solutions. All right, next we're going to check x plus y being equal to 2. And the only possible ordered pair here is 1, 1. But if I substitute x plus y being 2, we're going to get x cubed plus y cubed is equal to 2 squared, which is 4. But 1, 1 obviously doesn't work here, because if I substitute 1 and 1, that's not going to be equal to 4. In fact, that's going to be equal to 2, and that's not equal to 4. And yes, x plus y can be 1, can be 0, but don't forget the given at the start, x and y are natural numbers, so x and y must both be at least 1. Therefore, the minimum possible value of x plus y, the sum of x and y, it must be 2, where x and y are both equal to 1. So there are no more cases for us to check. And from the cases that we have 2, 2, we have the 2, 1, and the 1, 2. And there are no more solutions from any other cases, so the possible ordered pairs to the given equation, it's going to be 1, 2, 2, 1, and 2, 2. And these are the answers to this problem. All right, hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.